Hello students, in this video we are going to discuss questions from GATE 2024 Data Science exam. So let's discuss them one by one. So Euclidean distance based k-means clustering algorithm was run on a dataset of 100 points with k is equals to 3. If the points 1, 1 and minus 1, comma 1 are both part of cluster 3, then which one of the following point is necessarily also a part of cluster 3? So what it means? That means first we are taking Euclidean distance and we are applying k-means clustering algorithm, right? And we have taken k is equals to 3. So in a particular cluster, we have given already 2 points and they have asked me that which one of the point is also included in the cluster, right? So let's plot the point because we have to take a distance. So if I'll take a distance, so 1 comma 1 is somewhat here, right? Minus 1 comma 1 is here. And if I'll take 0 comma 1, 0 comma 1 here, right? Because I'm taking coordinates from the option. 0 comma 2, it would somewhat lie here, right? And then 2 comma 0, 2 comma 0 would be here, 2 comma 0. Then we have 0 comma 0. So now if I'll find out a distance, because they are saying Euclidean distance. So if I'll find out the distance of 0 comma 1 with 1 1 and minus 1 comma 1, they are in 1 unit of distance, right? They are 1 unit of distance from these points. So that means this point is closure, because you can see that if you will take 0 comma 2 distance with this minus 1 comma 1, what would you get? 2 minus 1 and 0 minus of minus 1, that means square root 2. So that means this distance is also square root 2. 0 comma 0 is also from square root 2 distance from the point minus 1 1 and 1 1. And similarly you can see that 2 comma 0 is very far away from the point minus 1 comma 1. And if I'll take a cluster including the point 1 comma 1 and minus 1 comma 1, so I'll form somewhat shape like that. So 0 comma 1 is always included. So that's why I can say that option A is the correct option in this, right? So that is, in this question, option A is correct. Now next question we have is again from machine learning. It says that consider a data set with 6 data points x1 y1, x2 y2 and up to x6 y6. x1 is given, x2 is given, x3, x4, x5, x6, these points are given and their labels are also given. That means y1, y2, y5 is labeled as y1 and y3, y4, y6 labeled as minus 1. Then they said that a hard margin linear support vector machine is trained on the above data set, right? Which one of the following set is a possible set of support vectors? So we have to tell them in above which one of the following is a possible set of above possible vectors. So that means from these options we have to tell them possible set of support vectors. So let's again plot this. So if I'll say 1 comma 0, so it is somewhat here 1 comma 0, right? And 0 comma 1 is here, 0 comma 1 is here, minus 1 0 comma minus 1, so that means 0 comma minus 1. And then we have minus 1 comma 0 here. Then we have the next point, that is 2 comma 2, and we have another point that is minus 2 comma minus 2, right? Now you can see that y1, y2, y5, that means let's consider these points. This is x1 and oh sorry, this is x1, this is x2 and x3 is 0 comma minus 1. This is x3, this is x4, this is x5, this is x6, right? So these are all the points on 2D plane, right? So they are saying y1, y2, y5 is equals to 1. That means x1, x2, x5 are labeled as 1. And if I'll take as x3, x4, x6, that means they are labeled as minus 1. Now I have to tell them that a possible set of support vectors. So if I'll say a margin line, I have this. So if I'll take support vectors, so x1, x2, x4, x3, that would become a support vector. So that means option A is true. And you can see that x3, x4 and x5 cannot be support vectors here. x3, x4, x5 is very far away. x5 because you can see that x5 before x5 we have x1 and x2. Similarly, if I'll talk about x1, x2, x5, x1, x2, x5. So because these points are closure, right? Similarly, x4 and x5, x5 and x4, again before x5 we have x1, x2, which would be closure, right? Because you can see that there would be a partition between x1, x2, x5 and x3, x4, x6. right? So that's why option A is true. Now, next question. Next question we have is, consider 5 random variable u, v, w, x, y whose joint distribution satisfy probability of u, v, w, x, y is equals to probability of u into probability of v into probability of w given u, v, probability x given w, probability y given w. So they ask me which one of the following statement is false, right? So let's see. If I'll write down here, w is, x is dependent on w, right? Because I can see that probability x given w and y is also dependent on w, and then w is dependent on u, and then it is v, right? U and it is v. Now they are saying that x is conditionally, and we have to tell them which one of the following statement is false. X is conditionally independent of u given w. So I can say that x is conditionally independent of u given w, right? That is true. Y and x are conditionally independent given w, right? They are independent given w. Y is conditionally independent of v given w. Again, y is conditionally independent of v given w because we do not have w give probability of y comma w given v, right? U and v are conditionally independent given w. So they are saying that u and v are conditionally independent, right? U and v are conditionally independent, and I can see here that these u and v are not conditionally independent because they depend on w, right? So they are not conditionally independent. So D is incorrect. So D is a correct option, right? And I have to tell them which of the following is false. So U and V are conditionally independent statement is false, right? Now, next question we have is, consider a data set with k binary valued attributes for a two class classification task. The number of parameters to be estimated for learning a naive based classifier is. So again, for a naive based classifier, so you can see that it is distributed in 2 classes. So we have 2 classes as an output, and you can see that k binary valued attributes. So we have k valued attributes. So I can say that x1, x2, xk, these are the attributes, and we have 2 classes. So we have to tell them number of parameters to be estimated. So we have to find the number of parameters which has to be estimated. So how do we estimate these parameters? So how many parameters I have to estimate? So first of all, I have to find out for each attribute with each of the class probability. That means 2 into k probabilities I have to find out, and for one probability I have to find out for this class. Because we have 2 classes. So if one probability I find out myself, another probability would become 1 minus probability of, let's say this one is u, right? This would become I can find directly, right? So we have only one value which we have to find using naive based classifier. So 2k plus 1 parameters to be estimated. So option B is true, right? So here option B is true. Now, next question we have is from mathematics. It says that for any twice differentiable function f from real number to real number, if at some x star belongs to R, f dash x star is 0, right? And they have given me that double derivative at that x star is greater than 0. Then function f has necessarily. So I have to tell them f has local maxima, local minima, global maximum. So we know that in calculus that we have a second derivative test. In second derivative test, if f dash x is equals to 0 and double derivative is greater than 0, then we have a local minima, and it would be local because there may be a possibility that we have number of minimas, because at x star I from this statement I can know that okay, we have one minima here, but there can be multiple minimas. So that's why local minima is correct option, right? So this option is correct. Now, next question we have is says that, consider the following 2 tables, name, raider and team in a relational database maintained by a kabaddi league. The attribute ID in table team references the primary key of the raider table ID. Okay, so we have given this raider table and we have given this team table, right? Now this says that the SQL query described is executed on this database. select star from radar comma t. So we have to select from radar comma t, right, from these two tables, where radar dot id is equals to team dot id. So we have to match that, where radar dot id is equals to team dot id, and city is equals to Jaipur, and rate points is greater than 200. So that means we have to combine these two tables such that city is equals to Jaipur and rate points is greater than 200. So first of all, let's see in this, where we have city Jaipur, this one and this one. These three cities are Jaipur, and you can see that if I'll see this, it has ID 2, so it goes to Ankush. Jaipur, it goes to 1, right? And it has ID 6, so it goes to Gopal, right? Now I have to count that how many rate point in how many cases I have rate points greater than 200. That would my query would give me, right? So this 250, 219 and 215. So all three have rate points greater than 200, right? So I can say that here. Uh, Let me see what is a correct. Okay, so you can see here the number of rows returned by this queries, right? So number of rows returned, that is 3. So you can see now the complete question. The complete question is that number of rows returned by this query. So number of rows returned, that is 3 rows returned by this query, right? Simple query problem, SQL query problem. Now next question we have, it says that sample average of 50 data point is 40. Updated sample average after including a new data point is become 142. Then we have to, okay, so new data point is 142. We have to tell them updated sample average. So that means x1 plus x2 plus x50 upon 50 is equals to 40 given to me. That is mean of 50 number is 40, and they told me to add 142. That is a new number. So what I can do, x1 plus x2 plus x50 is equals to 2000, and I have added new number. That is new number would be x51, and it would become 2000 plus 142, right? And they asked me to find out an average, right? So what would I do to find out an average? I'll divide it by 51. So it would become 2142 divided by 51. If I'll cancel out 4 and 2, okay, so it would become 42, right? So here updated sample average is 42. Okay, now next question we have is this matrix. A matrix is given to me 2, 3, -1 and 1, and they ask me to find out eigenvalues of M are non-negative and real. One eigenvalue of M is non-negative and real, and another eigenvalue of M is negative and real. Eigenvalues of M are complex conjugate pairs. One eigenvalue of M is positive and real, and another eigenvalue of M is 0. Okay, so let's see. So we have this M matrix. To find out an eigenvalue, I'll solve determinant of M minus lambda. That means 2 minus lambda minus 1, 3, 1 minus lambda, right? So if I'll solve this, what would I get? 2 minus lambda into 1 minus lambda plus 3, right? So it would become 2 minus 2 lambda minus 2 lambda minus lambda plus lambda square plus 3. So it would become lambda square minus 3 lambda plus 5, right? This would be my equation. Now I have to equate it with 0 to find out an eigenvalue. So to find out an eigenvalue, the formula is to solve a quadratic equation minus b plus minus square root of b square minus 4ac upon 2a. So let's do that. B square, that means 3 square minus 4 into 3 into 5. Sorry, 4 into b square minus 4ac. 4 into 1 into 5. B square square root minus b plus minus minus 3 plus minus, right? Let me write down it again. Yeah, the formula would be lambda value would be minus 3. That means 3 plus minus square root b square. 3 3s are 9 minus 4ac. 4 into 1 into 5, right, upon 2a. That means 2. So it would become 3 plus minus. If I'll solve this, I'll get minus 11. Square root of minus 11 would be 11 square root of 11 iota upon 2. So that means both roots are complex. So I can say that eigenvalues of M are complex conjugate pairs. Right? Eigenvalues of M are complex conjugate pairs. Now, next question we have here is, in adversarial search, alpha beta pruning can be applied to a game trees of any depth, where alpha is value choice we have formed so far at any choice point along the path for the max player, and beta is the dash value choice we have formed for at many choice along the path for the mean player. Which one of the following choices for M and N makes the above statement valid? So what does maximum player do? Maximum player would maximize its chances for winning, and alpha what is doing? Alpha is maximizing its chances. So that means it would take highest value up to what we have worked on, right? So M goes for the highest, alpha goes for the highest. Similarly, for the mean player would minimize another person's chances. So it would select the minimum value choice, right? So that's why M is highest and N is lowest. So which option is true? Option D is true here, right? Option D is the correct answer. Now, next question we have is, consider performing depth first search on an undirected and unweighted graph G starting at vertex S. For any vertex U in G, D of U is length of shortest path from S to U. That means, let's say if I have started from the S goal and we have reached to U, let's say somewhat we have some vertices in between them, then D of U denotes the length of the shortest path. And they are saying that U comma V be an edge in G such that D of U is less than D of V. Okay, so we have another vertex in G such that D of U is less than D of V. If the edge UV explode first in the direction from U to V during the above DFS, then U comma V becomes a dash edge. So we have to tell them that what this U comma V becomes a edge, right? If the edge U comma V explode first in the direction from U to V, so that means we can explore from the direction U to V, this edge. But cross edge is what? Cross edge is that neither U is ancestor, neither V is ancestor, right? So if we have this kind of a graph, let's say this is U and we have then later this is V, right? So then neither U is an ancestor of V, neither V is an ancestor of U, then that is a cross edge. So that is not true, right? And if I'll talk about back edge is what? That let's suppose we have some S here, and then I can trace from U to V, right? So V is an previous ancestor for U, right? So that is not possible because we have given that D of U is less than D of V. This is also not true. And gray this gray name we give to a vertex for a DFS when there is a back edge, right? So C is also not true. So only option true is D. So it would something like, let's suppose we have a graph. So let's say this is U, then we have this is V, right? So option D is true. Now, next question we have is the fundamental operation in a double-ended QDR. So we have given the insert first, that means we'll insert a new element at the beginning, insert last, we'll insert element at the end, remove first, that means we'll remove the first element and return it. Remove the last element and return it for remove last function. So let's apply that. So in this question, okay, so they are saying that insert 10. So first, let's say we have an array. So I'll insert 10, then insert last. So first we have inserted 10 and from the back end side we will insert 32 from the last. Remove first. So if I'll remove first, now at this position A would become 10, right? Next is insert last, that is 28. So I'll insert 28. Next is insert last, that is 17. So I'll insert 17 here. A remove first. So now in this case A would become 32 because they are saying remove first. So it would remove that and return that element. Now they are saying A is equals to remove last. So remove last 17. So A would become 17. So in this question you can see that they have asked the value of A's. So what would the value of a would become? The value of a would become is 17, right? So 17 is the answer. Now, next question here is H1 and H2 be two admissible heuristic used in A star search. Which one of the following expression is always an admissible heuristic function? So admissible heuristic function are those functions who never overestimate, never underestimate. So if I'll talk about in these cases, we have only this function which does not overestimate and does not underestimate. So option B is true because it would overestimate, and it would underestimate, right? So that's why modulus of h1 minus h2 gives me the correct answer. So the question here is f is a function from real number to real number, and the function is defined as 1 upon 1 plus e to the power minus x, and they ask me to find out the derivative of fx where fx is equals to 0.4. That means where the function takes the value 0.4, we have to find out the derivative. So let's first find out the derivative of the function f dash of fx. F dash x would become, I'll use the derivative rule, 1 plus e to the power minus x whole square, and let's keep 1 plus e to the power minus x as it is, and differentiation of 1 plus e to the power minus x is 0, minus 1 as it is, differentiation of 1 plus e to the power minus x would be minus e to the power minus x. So it would become, this derivative would become e to the power minus x 1 plus e to the power minus x whole square, right? So how do I solve it? So now you can do one thing here. If I'll write down this as 1 minus e to the power, let's take 1 plus 1 upon 1 plus e to the power minus x square, and let's write down e to the power minus x upon 1 plus e to the power minus x square. Now, sorry, not square, let's keep these square, let's remove these square. So now you can see that I have break down this function, and you will see that why I have break down 1 upon 1 plus e to the power minus x, and can I write down this function as 1 minus 1 upon 1 plus e to the power minus x? It both would give me same results, right? If I'll solve this, I'll get this function. So now I know that fx is equals to 0.4. So this is what? This is fx, and this would become 1 minus fx. So now I have to find out the derivative when fx is 0.4. So let's put fx is 0.4. 1 minus 0.4. Simple question. 0.4 into 0.6. 0.4 into 0.6. That would give me 0.24. Right? 0.24 is the answer. And guys, this function is what? This is sigmoid function, and we have done this derivative thing. That derivative of a sigmoid function is fx into 1 minus fx in logistic regression as well. Okay, so you can use the direct formula if you remember that. Okay, now next question we have is match the items in column 1 with the items in column 2 in the following table. So this is a direct question. So what we do in principal component analysis, so this side I have given the algorithm, and this side their modeling property. So principal component analysis helps me to reduce the dimension, right? And naive Bayes classifier is my generative model, right? Naive Bayes classifier is a generative model, and logistic regression is my discriminative model. So let's see which option is true. Option A is true based on this, right? So we know that about these algorithms, what about their model using these algorithms, so we can take the option. Now next question we have is, consider the following three traversals on a full binary tree. So we have given pre-order, in order, post order. So which of the following traversal option is /r sufficient to uniquely reconstruct the full binary tree? So uh, which of the following traversal option? First and second, that means I can use pre-order and in order. First and third, that means I can use pre-order and post-order. Second only, that is in order. Second and third, that means in order and post-order. So we know that single in order would not be sufficient to traverse a full binary tree. But if I'll use in order with pre-order, in order with post-order, that would work, right? So that means you can see that second and third option and first and second option both are true. Second and third, first and second. And also if I'll use pre-order and post-order, then I can also traverse the graph. So here ABD options are true, but this in order single option cannot be true. Single in order cannot help me to traverse the full binary tree. Okay, Now next question, we have given this matrix M and they ask me to find out determinant of M square plus 12M. So first of all, we know that determinant of M square plus 12M, I cannot break determinant of M square plus 12M as determinant of M square plus 12 into determinant of M, right? So what would I do here? Instead of that, first find out the determinant of M. If I'll find out determinant of M, so that would become, so you can see directly 1 plus 3 is 4, 2 plus 1 is 3, 3 plus 3 is 6. That means sum of two rows, sum of first two rows is equals to third row. So if we get something like that, we'll say that determinant is 0. So here determinant of M is 0. So if determinant of M is 0, so that means one of the eigenvalue of 0, one of the eigenvalue is 0. So that means eigenvalue of M square is 0, eigenvalue of M is 0. So that means determinant of M square is 0, determinant of 12M is 0. So overall determinant would become 0. Right, so I can break determinant of M square plus 12M. Determinant of M square plus 12 into determinant of M. Determinant of M is 0. And what about M square? But I cannot write down determinant of M square, would be determinant of M ka square. So what would I do for that? For that, I'll use that M has one of the eigenvalue M has 0. Then because M has determinant 0, so product of eigenvalues would be 0. So that means M has one of the eigenvalue which is 0. So that means M square has one of the eigenvalue which is 0. Right? So that means determinant of M square is 0. Right? In that case, sorry. Determinant of M square is 0 and determinant of M is 0. So that's why determinant of M square plus 12M is 0. So 0 is the correct answer. Now, next question we have is consider the following statement, and the statement are given to me: mean and variance of a Poisson random variable are equal. So we know that if I'll talk about Poisson random variable, its probability density function would be e to the power minus lambda, lambda to the power x upon x factorial. This is probability density function and its mean and variance both are lambda. So that means first option is true. Right? For a standard normal random variable, mean is 0 and variance is 1. Yeah, that is the definition of standard normal variable. Right? In normal distribution, we have mean mu, variance sigma. If I'll replace mu with 0 and variance with 1, then we'll get standard normal distribution. So that means in this case, both first and second are true option. Right? Both first and second are true. Now, next question we have is x and y be two propositions. So which of the following statement is /r are tautologies? So we have to tell them that which of the following statement is our tautologies. So you can see that in statement A we have given x and negation of y implication x, right? So one thing to notice here is that if I'll try to form a truth table, that would be a little bit lengthy, right? So what would I do? I know that it would be false when this particular is true and this particular is false. So what would I do? I'll take that it is false and I'll find out the value of x and y such that I'll get it false. If I do not get any value for y and x such that it is false, I'll say that it is true, right? It is a tautology. So what would I do? For this statement to be false, this has to be true, this has to be false. That means x is false, y is true. So if I take x is false and negation of y, that is true, so it would become false, right? So it would become false. So this cannot be true. So that means if this statement is false, this cannot be true. So that means this is a tautology, because in overall we do not get a false value, right? We get a true value always. So similarly for this one, let's consider this right hand side as false. So that means this is true, this is true, this is false. So can I take this value x as false? Why I am taking x as false? Because negation of x is true. X is false, y is false. So if I'll take negation of x, that would give me true and y would give me false. So overall I'll get a false. So that means false implication false, that would give me true, right? So that means if right side is false, then the left side is also false. Now next thing, let's come to this one, negation of x implication y. Again let's take this as again take this negation of x as true and y as false. So negation of x is true, y is false. Then in this case x would become false, right? X would become false, that means false and negation of y. false and negation of y, negation of false, that means true. False and true gives me overall false, so that means false implication false. Again this is a true, because I am not able to find out any x and y such that I'll get the truth value true, truth value false. So let's consider this. Let's take y is equals to true and x is equals to false, right? Overall this would give me false. Now let's come to this. If y is true, if y is true and x is false, negation of x would be true. So that means true and true gives me true. So that means this is true, this is false, true implication gives me false. So that means there exists some values of x and y, that is x is false, y is true, that means I'll get the truth value false. So that means this is not a tautology. So they ask me is are tautologies. So a is a tautology, b is a tautology, c is a tautology, right? That is a correct approach. If you try to form a truth table, that would take too much time to solve this. Okay, now next question we have is consider a database that includes the following relation: defender, that has name, rating, side, goals. Forward has name, rating, assist, goals. Then we have a team that has name, club and prize. Which one of the following relational algebra checks that every name occurring in teams appears in either defender or forward, where phi denotes the empty set? So that means in this case we have to tell them that which of the following query tells me that every team name occurring in a team, every name occurring in a team appears in either defender or forward, right? So when will I get this? And we have, you can see that in the right side we have given empty set. So you can see here that if I'll remove all the defender or forward team names, then I'll get an empty set. Then I'll say that okay, that query, if that query is giving me this result, then I'll say that that query is correct, right? So that means if I'll remove all the team names from all the names from defender and forward, then team name would be empty. So you can see that which of the option gives you the correct answer. So you can see that what you are doing in this, you are taking defender and forward names union, right? And then you are removing it from the team, right? So you can see that if you are getting a 5, so that means this is correct option. Option B is correct, right? None of the option is correct. It is saying that if it is, now you can see that it is saying either, but this option is saying both, right? So that's why option B is true and these two are not at all true. Okay, so option B is true in this. Now next question we have here is consider performing uniform hashing on an open address hash table with load factor alpha is equals to n by m, where n elements are stored in the table with m slots. The expected number of probes in an unsuccessful search is at most 1 upon 1 minus alpha. Inserting an element in the hash table requires at most. So it would be same, right? So how, the number of expected number of probes in an unsuccessful search is 1 at most 1 minus alpha. So that would be same for inserting an element in the hash table. So that means 1 upon 1 minus alpha. Okay, now next question we have is match the following column with items in the column 2. So you can see that in column 1 we have given the operations and in the second we have given queues, hash table and stacks. So we know that in queue we have first in first out, right? What we'll uh, first put it in the queue, that would exit first, right? That's how queue works. Let's say if I'm putting 1 2 3 4, so first I have put 1 2 then 3 then 4. If I'll have to remove, then first 1 would go, then 2 would remove, then 3 would remove, then 4 would remove. So first in first out, that is queue, right? You already know this is simple thing, right? Lookup operation. So lookup operation we use in hash table because hash tables help me to find out a uniform value, right? So that is lookup operation. Last in first out, that is stack, because what stacks do? So let's say if I'll put 1 2 3 4, so the number which I have put it in last get removed first. So last in first out, right? So let's see which of the option matches. P is second, and then Q is third and R is first. So option B is true, right? So B is a correct option here. Now next we have here is three fair coins are tossed independently. T is the event that two or more tosses result in head. S is the event that two or more tosses result in tails. Right? So T is the event that two or more tosses results in head. So that means T is equals to head head tail or head head head. These two conditions, two or more tosses results in head, and S is a event that two or more tosses results in tail. Tail tail head and tail tail tail. So you can see that T intersection S is phi. T intersection S is phi. So I can say that probability of T intersection S is nothing but 0. Right? So option D is true. So here D is the correct option. Now, next question we have is consider sorting the following array of integers in ascending order using an in place quicksort algorithm that uses last element as a pivot. So we have this array, and the minimum number of swaps performed during the quicksort is. So first you can see that this is what? This is a sorted array. So that means we do not have to perform any swaps. So that means minimum number of swaps 0. Right? 0 would be the minimum number of swaps. Now this is another question based on machine learning. It says that for any binary classification data set, SB and SW be the between class and within class scatter matrices. Okay. The Fisher linear discriminant is defined by U star that maximizes J of U is equals to U transpose SBU upon U transpose SWU. If lambda is equals to JU star, SW is non-singular and SB is not equals to 0, then U star comma lambda must satisfy which one of the following equations. So we have given the equation. So first of all, to maximize any function, just get back to basic mathematics. To maximize any function, if it gets maximized, its derivative would be 0 at that particular point. That means JU star would be 0. Sorry, del J by del U would be 0. Right, at U star. So let's find out first del J by del U. Right, so let's find out the differentiation. So this is what? This is in denominator, and let's put this del J by del U as equals to 0. So first of all, I'll take denominator ka square. That means U transpose SW U square equals to 0. Let's take the derivative of this. So denominator as it is U transpose SWU into D by du, derivative of U transpose SBU minus, let's keep U transpose SBU as it is, and D by DW, D by DU as U transpose SWU, right? And it is nothing but equals to 0 because we have to find out a maximum, right? So if it is equals to 0, this denominator would go to the right hand side, so it would become 0. Now this U transpose, let's keep U transpose SWU as it is, derivative of this, because it is U transpose U, that is U square, that so derivative would be 2U. So it would become 2U SB minus, or let's write it down, 2 SBU minus U transpose SBU, and let's write down this as 2 SWU equals to 0. Right, this is a derivative. Now let's first divide it with, if you would divide it by U transpose SWU. So let's divide the whole equation by 2 U transpose SWU. Let's divide it by that. So you can see here that this U transpose SWU cancel out, 2 and 2 cancel out. You are only left with here SBU equals to, or let's not keep it equal now, minus U transpose SBU, and if you will take it this to the denominator, 2 and 2 get cancelled, and you can see that SWU upon U transpose SWU. Okay, so you are not getting anything. So instead of that, what would I do? You can see that U transpose SBU and U transpose SWU, what it would become? It would become J of U. So can I write down here J of U? Let's write down this as J of U right? And this 2 gets cancelled and you are left with SWU equals to 0, right? And you know that this condition you will get at U star. Why you get at U star? Because of maxima, because at equals to 0 we are getting a maxima. So let's keep it. Can I write down here U star? Nothing would get changed. So SB U star, this would go to the right hand side. Can I replace JU star by lambda? Right, so let's keep it lambda SW U star. So let's keep this U star as it is. If I'll take SW to the left hand side, SW to the left hand side, it would become lambda, because lambda is a constant, right? So I can take W as W inverse SB U star is equals to lambda into U star. So see which of the option matches. Option D matches to my answer. So D is correct. So basic mathematics we have to use for differentiation, right? Because we have asked for a maximum value. Okay. Now, next question we have is minimum, maximum, mean and standard deviation values for the attribute income of data scientists be given. That is 46,000, 17,000, 96,000 and 21,000 respectively. Thus, Z score normalized income value of 1 lakh 6,000 is closest to which one of the following option? So, Z score, the formula for Z score we all know is equals to x bar minus mu, or let's say x minus mu over sigma, right? So you can see that we have given minimum and maximum value that are no use of us, right? It is of no use. So x is what? 1,06,000 minus 96,000 upon 21,000, right? So it would become, if I'll solve this, 96 subtract 96 out of 106 gives me 10,000 upon 21,000, get cancelled. If I'll take point, okay, 100, okay, it would become 0.476 something. So option B is correct here, right? So here option B is correct. So basic calculation we have to do for Z score. Now, next question we have is consider the table below where I comma j is an element of the table, is the distance between the points xi and xj. Single linkage clustering is performed on data points. First of all, we have to do a hierarchical clustering, and in single linkage clustering, we have to find out a minimum distance, right? So which one of the following is the correct representation of the clusters produced? So you can see that these are the representations given. So let's see, let's form a, let's combine these clusters. Let's do a hierarchical clustering using single linkage clustering, right? So first of all, I'll find out a minimum distance. So I can see that this is a minimum distance, 1 is a minimum distance. So that means if I'll, in first step, in first clustering, first we have x1, x2, x3, x4 and x5. In the second step we get, so in the at the first we have 5 clusters, at the second step we get 4 clusters, x4, x5, right? 4 clusters. Now I have to find out a distance between these two. So let's form a table x1, x2, x3 and then x4 comma x5, and we have x1, x2, x3, x4 comma x5. Okay, so let's find out this distance. So x1 with x1 is 0 and x1 with x2 is 1. x1 with x3 is 4. Now I have to find out distance of x1 with x4 and x5. So I know that I have to take a minimum distance. So x1 distance with x4 is 3. x1 distance with x5 is 6. So I'll take 3 distance. Right? Now, next thing is x2 distance with x1, that is 1. x2 distance with x2 is 0. x2 distance with x3 is 4. Now, x2 distance with x4 and x5 is 5 and 3. So it would become 3. Right? Now, x3 distance with 4 for x1. So it would become 4, 3, 0. Now, x3 distance with x4 and x5, that is 2 and 5. So we'll get 2 here. Now x4 distance with x5, so let's write down this as same, and x4 comma x5 distance with x5. Now I'll take again the minimum value. So I can see that minimum value here is 1. So in the third case, we got this cluster x1 comma x2, these two get combined and we get this x4 comma x5, right? Now I have to find out again the distances, so let's do that again. Can I able to do it here? I don't think there would be enough space, so I'm writing it here. So let's write down it here, x1 comma x2, this is one cluster, x3 and then x4 comma x5, right? x1 comma x2, okay, x3 and x4 comma x5. So x1 distance, x1 x2 distance with x1 x2 is 0 and x1 x2 distance with x3. So what would I do? I'll find out d of x1 with x3 and d of x2 with x3, right? That's what I have to do here. x1 with x3 is 4 and x1 with x2 with x3 is 3. So we'll get a distance 3 here. Now x1 x2 with x4 x5. So x1 x4, this I have to find out, x1 x5, and then I have to take x2 x4 and x2 x5. That means I have to take a minimum of these values. x1 with x4 is 3, x1 with x5 is 6, x2 with x4 is 5 and x2 with x5 is 3. So we'll get a distance 3. Right, now let's find out distance of x3 with x1 and x2. We have already find out that is 3. x3 with x3 is 0. Now x3 with x4 comma x5. x3 distance with x4, that is 2, and x5, that is, so we'll get here 2. So it would become now here 3 x4 x5, right? 2 and 0, right? So I can say that, see that the minimum distance is 2. So that means this gets combined, x1 comma x2 and then x3 x4 x5, right? And then the last step, we get combined all of them, right? So this is a hierarchical clustering using single linkage. So let me remove this and see which of the option matches to our answer to the next slide. Okay, let's see to the next slide. So first we have combined x4 x5 and then we have combined x1 x2, okay, and then we have combined x3 with x4 x5 and then we have finally combined. So which option is true? Option D is true here, right? Option D is true here. So you can see that that's how we'll do single linkage clustering. Just only thing to remember here is that we have to find out a minimum distance. So we have given this Python code and they have said that definition count, we have given this function which takes two values, one dictionary and one comma I value. If I not in child dict dot keys, it would return 1, answer is equals to 1. For j in child dict I, answer is equals to answer plus count child dict comma j. That means I have to run this function again, return answer, right? So we have given this dictionary which takes 0 at 0th index, it takes value 1 2, and at first index it would take 3 4 5 and at second index it would take 6 7 8. Now I have to run this function, print count child dict comma 0, right? So this says to me which one of the following is the output of this code, and we have given this, these are the option 1 6 9 8. So we have to tell them that which of the out of 1 6 9 8 what would be the correct output. So let's see. So first of all, I can see here we have to run child dict comma 0 and we have given a dictionary, right? So I is equals to 0. So it says that if 0 is not in child dict dot keys, but in in keys of child dict we have 0, right? So this would not run. So in at this point answer is equals to 1. Now for j in child dict I, right? So child dict I would become 1 2. So I'll take first value 1. So j is equals to 1. If I'll take j is equals to 1, answer is equals to answer plus count child dict, dictionary remains same, it would become value 1. It would become 1, and you can see that this is a for loop, so that means it would run 2 times. So that means we'll have value count is equals to child dict, comma 2. So that means we have to run this 2 times, because in this 0th index we have 2 values, 1 2, right? So it would run for 2 values. So we have one thing here. Now I have to run this function count child dict comma 1 to find out this value, and this answer here is 1. Why it is 1? Because at the start I have the value 1. So let's run this function count child dict comma 1, right? I have to run this. So let's go to the definition. Now I would become 1, right? If 1 not in child dict dot keys but 1 in child dict keys, na, then answer is equals to 1. Answer would become 1 because 1 in the keys. Now for j in child dict I, answer is equals to answer plus count child dict j. So that means count child dict, that means it would run for 3, because now it would become I is equals to 1 here. I would become 1 here, so it would take the array 3, it would take the value 3 4 5. So j would run for 3, j would run for 4, j would run for 5. So it would run for all the values. Count child dict 4 and plus count child dict 5, right? Child dict 5, right? Now let's run for, now I have to run for count child dict 3. If I run count child dict 3, so 3 is not in child dict dot keys, so 3 is not in child dict dot keys. You can see that we have only keys 0 1 2, so that means it would return 1. So it would not run this. For j in child dict dot I, so j in, so we do not have that because it is not in keys, right? 3 is not in keys, so it would not run. We will get here 1 value, it will return 1, right? So this would not run, it would return 1. Similarly for child dict dot 4 comma 4, it would return 1, it would return 1. So it would become 1 plus 1 plus 1 plus 1, that is 4. So here from this count child dict comma 1, we get the value 4. Similarly if I run count child dict comma 2, right? Count child dict comma 2, if 2 not in child dict dot keys but 2 in child dict keys, so that means it would run. For j in child dict, that is 2, that would give me 6 7 8, so it would run for 6 7 8. So that means it would run similarly as it is. So for this one as well, we will get a value. Answer is equals to 1 plus 1 plus, for 6 I'll get 1 because 6 is not in keys, so it would return 1. For 7 is not in keys and for 8 is not in keys, so we'll get 4 4 4 we get from here, and final answer we have that 1 plus 4, that would give me 9. So here 9 would be the output of this code, right? So you would get an output as 9. So option C is correct here. That's how I'll run the code based on this, based on dictionary in Python. Next question we have is, given the two-dimensional data set consisting of 5 data points from two classes, circles and square, assume that Euclidean distance is used to measure the distance between 2 points. The minimum odd value of k in k nearest neighbor algorithm, for which the diamond shaped data point is assigned the label square is. So that means diamond shaped data point is assigned the label square. So I have to take what value of k such that diamond shape is assigned a square. So first of all, let's say if I'll take k is equals to 1, because I have to take odd value, so I am just trying to find out which odd value would work. And they ask me to find out minimum value of k. So I have started from 1. If I'll take k is equals to 1, so the nearest point is this point, 1 unit of distance. So in this case, it would assign circle, but we have to assign diamond shape square. So this would not work. If I'll take k is equals to 3, if I'll take k is equals to 3, then this is the nearest, this is the nearest, this is the nearest. So it would take these 3 points, right? Then the next thing would be, if taking these 3 points, I'll count number of circles and number of square, right? Number of circles 2, number of squares 1. That means circles are greater. So that means this diamond shape get assigned circle value, right? Get assigned the circle, right? So that's why this is, or this would also not work. Now k is equals to 5. Now if I'll take k is equals to 5, so all the 5 points would come. This would be the circle, right? And if this would be the circle, you can see that this 3 points are square and 2 points are circles. So 3 points, the number of square are more than number of circles. So that's why we'll assign square to the diamond. So that's why k is equals to 5 work. So that means minimum value of the labels, minimum value of the k in k nearest neighbor is 5. Okay. Now, next question we have is consider the following Python function. So we have given a function here. You can see definition function d comma s1 comma s2. If s1 is less than s2, d of s1 comma d of s2, d of s2 comma d of s1. That means we are replacing and then we are applying this algorithm again on s1 plus 1 and s2 minus 1. That means let's suppose we have given this array 1, 2, 3, 4, 5, 6, right? I have this array. So what I am doing here, if s1 is less than s2, so let's take these two. Let's take the index 0, 1, 2, 3, 4, 5 because I am taking here index. I can see from here because d of s1 is same. So 0 is less than 5. So d of these two values gets replaced by at this point. So 6 would become here and 1 would become here. Then 2, 3, 4, 5. Right? Then we'll add 1, s1 plus 1 and s2 minus 1. That means 0 plus 1, that is 1, and 5 minus 1, that is 4. So we'll see this index. Sorry. 1, 2, 3, 4, 5. We'll see this index. Now I'll replace these two. Right? Let's replace these two. So what will we get? 6, 5, 3, 4 and 6, 5, 3, 4 and 2 and 1. Right? Now again it would increase, take a increase 1 and subtract 1. Right? So 1, 4 would become 2, 3. Now it would replace these two values. So we'll get 6, 5, 4, 3, 2, 1. Right? Now if I'll increase 1 and subtract 1. So 2 plus 1, 3, 3 minus 1, 2. Right? So you can see that if I'll apply 3 comma 2 here, 3 is not less than 2. So it would not run. So it would stop at this position. So what it is happening here? It reversed my array. Right? So I can say that, let's see, it finds the smallest element. No. It swaps the element in D at indices S1 and S2 and leaves the remaining elements unchanged. No, it is remaining all the, it is swapping all the elements. It performs a merge sort. No, it is not sorting. It reverses the list D between indices S1 and S2 both inclusive. Right? So yeah, it reverses the list. So you can see that at the start I have 1, 2, 3, 4, 5, 6 and at the edge I'll reach to 6, 5, 4, 3, 2, 1. Okay, so that's how this function works. Now, next thing we have here is consider a joint probability density function of two random variable x and y, and we have given this fxy. So first of all, they told me that this is a joint probability density function, but if you would integrate this 0 to x, 2xy, dy, dx, and x goes from 0 to 2. So it would give me 2xy square by 2, that is if I'll integrate x square by 2 and then dx 0 to 2. 2 and 2 get cancelled, x to the power 4 by 4. Now if I'll put the limits 0 to 2, so it would give me 2, 2s are 4, 2s are 8, 16. So overall I'll get the value 4. So that means this is not a probability density function. So this question is incorrect in the GATE exam. Right, this was the incorrect question given, and they asked me to expectation of y given x is equals to 1.5. If I have to find out this expectation, what would I do? I'll first find out fy given x, right? Fy given x I have to find out, and then I have to multiply y into fy given x, and then I have to integrate y, right? So that would give me my expected value, right? But this question was wrong in the exam because the statement is incorrect. Now, they are saying that u is equals to vector 1, 2, 3, 4, 5 and sigma 1, sigma 2, sigma 3, sigma 4, sigma 5 with the singular values of the matrix. So we have given the singular values and they are saying m is equals to u into u transpose. Then the value of, okay, these singular values are of the matrix m. Then the values of all the singular values. So first let's find out u into u transpose. So if I'll write down u into u transpose 1, 2, 3, 4, 5. What would I get here? I'll get 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 3, 6, 9, 12 and 15, 4, 8, 12 and 16 and 20 and 5, 10, 15, 20 and 25, right? So sum of all the singular values is equals to trace of a matrix. So let's add these 1 plus 4 plus 9 plus 16 plus 25, right? Sum of all the diagonal entries, 9 plus 16 plus 25. On solving, that would give me 55, right? Right. It would give me 55. So 55 is a correct answer. Okay, now let's move. Okay, so we have this question. It says that details of 10 international cricket games between two teams, green and blue, are given in the table C. Okay, guys, table C, this is the table given to me. Okay, so you can see that we have match number, we have pitch, we have format, and then we have winner. That green team is a winner, blue team is a winner. That means we have two class. So here, this table consists of matches played on different pitches across formats along with their winners. The attribute pitch can take one of two values, spin friendly or pace friendly. Okay, spin friendly represented as S, pace friendly represented as F. The attribute format can take one of two values, one day match represented as O and test match represented as T. Cricket organization would like to use the information given in table C to develop a decision tree model to predict the outcomes of the future game between these two teams. To develop such a model, the computed information gains C comma pitch with respect to the target S. So we have to classify, we have to make a decision tree based on this pitch, right? So that means what they are saying, information gain C comma pitch. So that means I have to find out information gain of C comma pitch. So for that I have to first of all find out the entropy of this class, entropy of C. So what it would become, because I can see that I have 4 green and 6 blue, so it would become minus 4 by 10 log 2, 4 by 10, and minus 6 by 10 log 2, 6 by 10. This is the entropy of the table, right? Now because I have to divide it based on this pitch, right? So I can see that this pitch gets divided in S and F, and you can see that in this S we have these two S, this one S, this one S, this one S. So let's see, we have one green, one blue, one blue, one green, one green, 1 2 3 green, 2 blues. Okay, 3 green, 2 blues. In F case we have 1 blue, 2 blues, 3 4 blue, 4 blue, 1 green. Okay, right. Okay, so now I have to find out entropy for this S. So let's find out entropy of S. So what it would become, minus 3 by 5 log 3 log to the base 2, 3 by 5, minus 2 by 5 log to the base 2, 2 by 5. This is entropy in this S case, and in this F case entropy would become in F case minus 1 by 5 log 1 by 5 minus 4 by 5 log to the base 2, log to the base 2, 4 by 5, right? Now final entropy would be, final information gain, how would you find out? Now for information gain, the formula is information gain, entropy of this whole table, entropy, that means impurity in this whole table, minus how many values we have in S? 5. That means S has 5 values, 5 in total, we have 10 values, and we'll subtract entropy of impurity in S, and then minus 5 by 10, it gets subtracted entropy of F. So it would give me information gain in this case, right? So just solve this, all the calculation you have to do, so you would get one answer. So it would be something like 0.125, right? Okay, solve it. Now the next question we have is, an OTT company is maintaining a large disk based relational database of different movies with the following schema. Schema is movie ID comma customer rating, genre ID comma name, right? Movie genre is movie ID comma genre ID. Consider the following SQL query on the relation database above. So it says that select star from movie comma genre comma movie genre, where movie dot customer rating is greater than 3.4 and genre name is equals to comedy, and movie dot genre dot movie id is equals to movie id, movie genre dot genre id is equals to genre id. Okay, the SQL query can be sped up using which of the following indexing options given to me: hash index on genre name and b plus tree on remaining index, or b plus tree on all the attributes. Hash index on all the attributes, or we have another option, hash index on movie dot customer rating and b plus tree on the remaining attributes. Okay, now one thing to notice here is that b plus trees we use when we have a sequential data, right? So that means if I'll say that, and so that means when we have greater than 3.4, right? So that means we want some data in which we have all the values of customer rating greater than 3.4. So that means I can use b plus trees on this, right? I can use b plus trees because I want a sequential data. And if I'll talk about genre dot name is equals to comedy, so that means we want a uniform value, that is comedy. So that I can get from hash index. So that means hash index on genre name and b plus trees on remaining attribute. So that means option A would work. I'll apply hash index on genre name and b plus tree on remaining attributes. And also I can apply b plus tree on all the attributes, right? I can apply b plus tree on all the attributes, but I cannot apply hash index on all the attributes because hash index gives me uniform value, a single value. So it would not get applied on 3.4, greater than 3.4. Similarly, option D is also incorrect because hash index does not get applied on movie dot customer rating. So C and D are incorrect. Only option A and B are correct in this, right? Option A and B are correct option. Okay, now next question we have is compute s of x whose pseudocode is given below. So you can see that this function compute s of x, this takes s of 1, takes one value for I. If I'll put I is equals to 2 to length x, then s of I is 1, that means s of 2 is 1. If x of I minus 1 is less than x of I, s of I gets replaced with s of I plus s of I minus 1. And if and for return s, right? Which one of the following values is returned by the function compute s of x when x is equals to 6, 3, 4, 5, 10? Okay, so x is equals to 6, 3, 4, 5, 10. So this, you can see that here indexing is done from 1 onwards, right? Indexing does not start from 0, it starts from 1, 5, 4 and 10. This is my array given to me or list given to me. Now they are asking that, okay, so let's say s of 1 is 1. This is an array given to me, okay. So s of 1 is 1. So I have to find out s of x. So let's see. So first of all, s of 1 is 1. So let's put at 1 we have 1. Now I have to work for second value. So for I is equals to 2, that means s of 2 becomes I. S of 2 becomes I, that is one value, because s of I is equals to 1, right? I is 2. Now if x of I minus 1, that means if x of 2 minus 1, that means x of 1. If x of 1 is less than equal to x of 2, right? If x of 1 is less than equal to x of 2, then s of 1, then s of 2 would become s of 1 plus, sorry, s of 2 in plus s of 1, right? Let's see. X of 1 is less than x of 2. 6 is less than 3. No. So that means this would not run. So we will get s of 2 value. We get s of 2 value 1. So that means it would be 1. Now it would run again for 3. So what would it become? For I is equals to 2. Now I would become 3. So s of 3 would become 1. Everything else would work again. So let's see. Let's for 3. S of 3. S of 3 is 1. Okay. Now if x of 2 is less than equal to x of 1, x of 2 is less than equal to x of 3. X of 2 is less than equal to x of 3, then s of 3 would become s of 3 plus S of 2, right? So x of 2 is 3 is less than equal to 5. So these two values gets added. So that means 1 plus 1 we'll get 2. So that means we have to add previous value. Uh, if I have to add previous value if this is less than equal to, otherwise I'll not add. So let's see. So in first three cases I'll get 1 1 2. Now for the third position, for the fourth position, I'll take I is equals to 4. So I will say that 5 is not less than equal to 4. So I'll get 1. Now next case 4 is less than equal to 10. So 1 plus 1, that is 2. So I can see that which array I'll get. I'll get 1 1 2 1 2 as my answer. Right. So that's why I have to work on this. Right. I have to see stepwise what they are doing inside this code. Right. So here option A is correct. Now next question we have here is, given the following Bayesian network consisting of 4 Bernoulli random variables and associated conditional probability tables. So you can see here that we have given uh, conditional probability tables. That means u, probability of u is being 0 is 0.5, probability of u is equals to 1 is 0.5. Then we have probability of v is equals to 0 given u is equals to 0. Right, that means v is dependent on u. Similarly, W is dependent on U, and then Z is dependent on V and W. So we have to find out probability of U1, V1, W1, Z1. So how do I find out? So let's see. That means I have to find out probability U is equals to 1. Let me not write 1 right now. Let me write down these probabilities. U, comma, V, comma, W, comma, Z. Just remember all the values I have to find out probability for 1. So first of all, you can see that probability of Z is dependent on which? V and W. So V comma W. Then probability of, you will write down probability of V and W. Probability of V is dependent on U and probability of W is dependent on U into probability of U. Right? And you have to take all the variables 1. Right, probability of Z is equals to 1 when V is 1, W is 1. So let's see, probability Z is equals to 1 when V is 1, W is 1, that is 0.5. Okay, let me write down 0.5 here. Now probability V given you, probability of V given you, probability of V is equals to 1 when U is equals to 1, that is 0.5. Probability of W given you, that means probability of W is equals to 1 when U is equals to 1. So we have this probability as, we have given this probability as 1. And probability of U is equals to 1 is 0.5. Right. So just remember, for sake of not writing all the values so many times, so that's why I have written. You can write down 1 as well. Right. So if I'll solve this, what would I get this probability? 0.125. This is my final probability. Okay. So that's how I'll solve this. I'll find out a probability. Now, this is another question. It says that R be a set of real number, U be a subspace of R cube, and M is a matrix of order 3 cross 3. Be the matrix corresponding to the projection onto the subspace U. Then which of the following are true? So first of all, this says that if U is one dimensional, then the null space of M is one dimensional subspace. That is wrong, because you can see that R cube is what? R cube is 3 dimensional. If R cube is 3 dimensional, then if U is a 1 dimensional, then its null space would be 2 dimensional, because dimension of a subspace plus dimension of null space is equals to dimension of the main vector space, that is 3. So dimension of null space would be 2. Next option, so this is incorrect. If U is a 2 dimensional subspace of R cube, then null space of M is a 1 dimensional space, that is true. And options C and D are also true because of the properties of this projection matrix. Right, so that's why options C and D are also correct option. So here B, C, D are correct. Okay, next thing we have here is, consider two neural networks shown in figure 1 and 2 with ReLU activation. ReLU is what? You would take maximum of 0 comma that particular value Z. That means ReLU takes all the values positive. The connections and their corresponding weights are shown in the figure. The biases at every neuron set to 0 for what values of PQ are in figure 2 are 2, n's equivalent when x1 and x2 and x3 are positive, right? So we have given this neural network and we have to find out value of PQR. And guys, in the option you can see here, these are the option I have. Okay, now let's get back to the neural network. So first of all, when I'll pass through this x1, x2, x3 at this position, let's consider this as h1, h2 and h3, then h1 would become, so you can see that in h1 we are getting from x1 and x2, so that means 1 of x1 plus 1 of x2, 1 into x1 plus 1 into x2, and h2 would be x2, sorry, h2 would be, let me not write down 1 into, right, x1 plus x2, h2 would be x1 plus x3, and then h3 would be x1 plus x2 plus x3, right, because we are getting from all the values. And you can see that biases are 0, so I do not have to add any bias function, right? This is h1, h2, h3. Let's consider at this point we have h4 and we have h5. So if I'll find out h4 and h5, h4 and h5, h4 consists of h1, h2 and h3, all three values, and we have to multiply it with 2. So 2h1 plus 2h2 plus 2h3, right? Similarly h5 as well, 2h1 plus 2h2 plus 2h3, because it is taking all the values from all the three neurons. So I can see here, if I'll write down 2 of h1 and if I solve this, I'll get 6 of x1 and then 4 of x2 and then 4 of x3, right? Similarly h5 also, 6 of x1, 4 of x2 plus 4 of x3, right? Now at this point what would happen, I'll use 3h4 plus h5, let's consider this as h6, then h6 would become 3 of h4 plus 3 of h5. So if I'll solve this, 3 into h4 and 3 into h5, what would I get? I would get here 6 3s are 18, 36 x1 and 24 x2 and 24 x3. So you can see here we are getting 36, 24 and 24. So if I'll match the option, so which of the option? 36, 24, 24. So you can see here PQR 36, 24, 24 would be the correct value, right? So that's how we just have to pass all the values through the neurons and we'll get the final answer, right? So which option is true? Option B is true here. We have this question, f from R to R be a function. R denotes the set of real number and the function of x is defined by, if x is less than -2, then the function is minus x, and if x belongs to -2 to 2, the function is ax square plus bx plus c. If x is greater than 2, the function's value is x. Then they ask that which one of the following choices gives the value of a, b, c that makes function f continuous and differentiable. Right, so we want to know that at which point the function is continuous and differentiable. So for continuity, the functions at endpoints would be equal. That means limit x approaches to less than -2 would be equal to limit x approaches to -2 positive, right? Left hand limit would be equal to right hand limit. So in this case, if I'll write down limit x approaches to -2 negative, limit x approaches to -2 negative, fx would be equal to limit x approaches to -2 positive fx. That means minus x. If I'll put fx is equals to minus x, that would become uh, -2, minus of -2, right? And this would become ax square. That means a -2 square plus b into -2 plus c. So we get one equation, 4a minus 2b plus c is equals to 2, right? This is one of the equation. Now for x is equals to 2, we have to do the same work. So it would become, if I'll solve this, it would become 4a plus 2b plus c, right? We got these two equations. But I can see here we have three variables, so we need something more. So we have given the differentiability condition, so I'll find out f dash x. F dash x would be -1, 2ax plus b and 1. So if x is less than -2, then -1. If x lies between -2 to 2, if x is greater than 2, then we have this function. So I can write down from this here as well, 2a into minus 2 plus b is equals to minus 1, and we got one equation from here as well, 2a into 2 plus b is equals to 1. So we get one equation, that is minus 4a plus b is equals to minus 1, minus 4a plus b is equals to minus 1, and then we have 4a plus b is equals to 1. 4a plus b is equals to 1. So if I'll add these two equations, let's add these. So what would we get? 2b is equals to 0. So we get b is equals to 0. On solving, if I'll put b is equals to 0 here, I'll get a is equals to 1 by 4. And let's put in any of the equation, a 1 by 4, b 0. If I'll put a 1 by 4, b 0, c would become 1 here, right? And in this as well. So c would become 1. So I can see here that which option is true. A is equals to 1 by 4, b is equals to 0, c is equals to 1. So that's why option D is correct. So simple mathematics you have to do for continuity and differentiability. Okay, yeah. Now we have this next question. It says that consider a state space where the start state is number 1. The successor function for the state numbered n returns two states numbered n plus 1 and n plus 2. Assume that the states in an unexpanded state list are expanded in the ascending order of the number, and previously expanded states are not added to the unexpanded state. Which one of the following statement about breadth first search and depth first search is true when reaching the goal state number 6? DFS expands more states than BFS. BFS expands more states than DFS. Both BFS and DFS expand equal number of states, and both DFS and BFS do not reach the goal state number 6. Right? So this is a question. So now first of all, let's see what they are saying. That state space search, we have an initial goal, that initial start from 1, and the successor function returns two states, n plus 1 and n plus 2. That means one returns 2 and 3. So can I say that 1 return 2 and 3, right? And then 2 return 3 and 4, 3 return 4 and 5, 4 return 5 and 6, right? And then 5 return 6 and then 7, right? We do not have to go there because we have to reach up to goal 6. So what breadth first search do? Breadth first go in breadth wise, right? It would go for the first level, then second level complete, then the third level. Depth first search goes in depth. But if in this case you can see that if I'll go in depth, how would I go? 1 2 3 4 5 6, right? 1 2, and then I go to 2 3, right? Similarly in this case as well, in depth first search as well, 1 2 3, if I'll go in depth, I'll go according to the same rule, right? Because they are connected like that. So that means in this case both BFS and DFS expand equal number of states, right? So that's why option C is true here, right? Because you can see that 2 is connected with 3 and 4. So if I'll go in depth, I can go up to 2 is connected with 3 and 4, right? 4 is connected with 5 and 6. So I can go from 2 to either 3 and 4 in depth first search, and similarly in breadth first search I can go to 2 to 3, right? So that's why we have this, both BFS and DFS expand equal number of states. Now next we have is a relational, given the relational schema R, U, V, W, X, Y, Z, and the set of functional dependency. Functional dependency I have given U to V, U to W, WX to Y, WX to Z, and V to X. Then I have to check that which of the functional dependencies can be derived from the above set, right? From this set, how many functional dependency I can derive. So first let's see. So they are saying VW to Y, right? So let's see V. Where is we have V? V to X, right? If I can write down V to X, that means I can go and V to X, and they are saying VW. I have to take VW. So V to X I got, and VW I have here. So I can say that WX, because I got, because I have started with VW. I have V. From V I got X, and I already have W, then WX to Y. So I can say that VW to Y is correct functional dependency. I can get from above set, right? VW to U. Now V to X and then WX to Y. Okay, but you can see that U imply V and U imply W, but U is not implied by anyone. So we do not get that from here. So B is not a functional dependency from the above data set. I cannot derive it, VW to U. Then VW to YZ, right? Let's see VW to YZ. So again let's see, from V I'll get X, right? I already have VW, right? From V2 I can have X and VW, W I already have and X I got from V, then I can say that it is Y. So I already get Y, and from WX I can get Z. So I can say that from VW I reach to Y and Z. So that is also true. Now WX to YZ, I can see that WX to Y and WX to Z, I already got that. So D is also true, right? Because you can see directly here, na? So A, C, D are the correct option in this case. Okay. Now let's see next question. Okay, so we have to find out this limit here. So it says that limit x tends to 0 log x square plus 1 into cos x upon x square. So if I'll put 0 here, and it would give me 0 by log 0 and cos 0 is 1. So it would give me log 1. Log 1 is 0 and 0 by 0 gives me indeterminate form, right? One of the students said to me that you can break log x square 1 plus log cos x. But if you would break, right? I know you want to get your problem easy, but if you would break here log x square 1 plus log cos x and you would break down over x square, then you would not get indeterminate form. So there is no no shortcut we get after breaking it, right? So I'll differentiate it. I'll use L'Hopital rule. So what would I do? Limit x approaches to 0, let's differentiate 1 upon x square plus 1 into cos x, and let's differentiate this x square plus 1 cos x, chain rule. So x square plus 1 as it is, differentiation of cos x is minus sin x, differentiation of x square plus 1 is 2x, and then we have cos x, right? Then we have, and we have denominator differentiation 2x. Limit x approaches to 0, so we get a function minus x square plus 1 sin x plus 2x cos x. Okay, and then if I'll multiply this, so what would I get? 2 into x cube plus x cos x, right? Let's put x 0. If I'll put 0 again, I'll get 0 by 0 form. If I'm getting 0 by 0 form, that means I have to apply again L'Hopital rule, because that is again an indeterminate form. So let's do that. Limit x approaches to 0 minus, as it is, differentiation of x square plus 1 is 2x, and then we have sin x, minus of x square plus 1, differentiation of sin x is cos x, then 2x as it is, differentiation of cos x is minus sin x, and differentiation of x is 1, right? Let's differentiate denominator as well. 2 as it is, differentiation of x cube plus x, 3x square plus 1 cos x, right? Plus 2 as it is, x cube plus x as it is, differentiation of cos x is minus sin x, right? Now let's put x 0. If I'll put this in this term, I'll get 0. If I'll put in this term 0 plus 1, 1 cos 0 1, I'll get 1 here. From 0 to minus 1, so in numerator I'll get 2 minus 1, because from here I'll get minus 1 and then 2. If I'll put in denominator 2 into 3 into 0, so we'll get 2 plus 0. So we'll get the value 1 by 2, that is 0.5, right? So limit value would be 0.5. So here 0.5 is the correct answer. Okay, you just have to differentiate using L'Hopital rule. Now, next question we have is, if and denote the maximum number of comparison made while searching for an entry in a sorted array of size n using binary search. Which one of the following option is true, right? For a binary search, we know that for a binary search, we have this f of n is equals to f of floor function n by 2 plus 1 is true, right? So this is for binary search. You all guys know that. Now this is another question. It says that a fair six-sided die with faces numbered 1, 2, 3, 4, 5, 6 is repeatedly thrown independently. What is the expected number of times the die is thrown until two consecutive throws of even numbers are seen? So that means we have to find out two consecutive even numbers. So how do I get two consecutive even number? That means in the first case I'll get 2, 4, 6, and in the second throw I'll get 2, 4, 6, right? So then I'll get expectation, I'll get two even numbers, two consecutive even numbers, right? So there are two cases, that in the first case I'll get odd number, if I in the first case I'll get even number. If in the first case I am getting odd number, what is the probability of first of all getting an odd number? That is, sorry, 1 by 2, because we have 3 odd, 3 even. So 1 by 2 is a probability of getting an odd and even. So if I'll get an odd, then I have to start from the scratch. So that means our expectation would become expectation of x plus 1, because I have already used 1 through, and I have to first then move it again, right? If even, if it is an even through, then there are two possibilities again. I can get an even value and I can get an odd value. If I'll get an even value, that means 1 by 2. So we will get the probability 1 by 4. And because here I can get anything 246 and 246, so I can multiply it by 2, right? Because these numbers can get exchanged, right? For odd number, if I have even or odd, then I have to start from the scratch again, right? This is a probability 1 by 2, and I have to, because I have used two steps, so it would be expectation of x plus 2, right? So my expectation of x would become 1 by 2 expectation of x plus 1, right, plus 1 by 4 into 2 plus 1 by 2 in, into 1 by 2, or I can write down directly 1 by 4. 1 by 4 into expectation of x plus 2, right? So if I'll solve this, what would I get? 1 by 2 expectation of x and 1 by 4 expectation of x. So that would give me 3 by 4 expectation of x. And if I'll solve the remaining values, 1 by 2, 1 by 2, that is 1, and so it would give me 3 by 2. So if I'll solve this expectation, I'll take it to the left hand side. It would become expectation of, okay, it would become 1 by 4 expectation of x is equals to 3 by 2. On solving, you will get expectation of x is equals to 6. So 6 is a correct option here. Option B is correct, right? So here expectation of x is 6. Right, in this case expectation of x plus 1, because we have used one step, right? So we have to move forward to that. In this case we have added 2 because we have already used two steps. So expected value plus 2 it would become. Now this is another question. It says that consider a function f where f is a polynomial given to me. They ask me that local maxima, minima, we have to find that. So we can use second derivative test. So let's use that. First I'll find out f dash x. So it would give me x cube minus 2x square plus, not plus, it would become minus 3x equals to 0. I can take x common, I'll get x square minus 2x minus 3. So if I'll solve x square, sorry, x square minus 3x minus plus x minus 3 equals to 0. So x plus 1 and x minus 3, right? So x critical values would be 0, minus 1 and 3. I have to check at these points. Now I have to find out double derivative to check that where I am getting maxima and minima. So let's do that. Let's find out double derivative. So if I'll solve for double derivative, I'll get 3x square, okay, 3x square minus 4x minus 3. So let's check it at 0. So if I'll check it at 0, less than 0, so that means we'll have maxima here at x is equals to 0. Then I'll check at f double dash at minus 1. So minus 1 would become 3 plus 4 minus 3. So it would give me 4, that is greater than 0. That means minima, local minima. And if I'll solve for f double dash 327 minus 12 minus 3. That means 12, right? Which is greater than 0. That means we will have minima. So minus 1 minima, 0 maxima and 3 minima again. So 0 is a maxima, that is true. Okay. 3 is a minima, that is true. 0 is a minima, that is false. Minus 1 is a maxima, that is false. So A and B options are true. Option A and B are my correct option in this. Like basic use of double derivative test. Okay. Now next thing we have is consider the directed acyclic graph below Which of the following is our valid vertex orderings that can be obtained from a topological sort of DAG? So we have to take a topological sort, right? We have to sort topologically. So first of all, I'll move from P. Then for Q, I have to move to R as well, right? Then I'll move to Q. So P, R, Q. Now I have two options. I can move either to S and V. So that means P, R, S, sorry, P, R, Q, P, R, Q, and I can move Q to S, and I can move P, R, Q to V, right? Then for U or T, I have to move so from V to I have to move to S, and from S to I have to move to V, right? Then from S to V, then I can move to U, and then I can move to T, right? Similarly, from S I have to move to U, from S I can move to, sorry, from S I, just a minute, P, R, Q, okay, V, S, right? We have moved from V, S. Now from S to U and then T. From here V, I think, yeah, from S to V, okay. From V I have to move to, from V I have to move to T, and then I have to move to U, right? So that's how we'll move. So first, for topological order, we have to move like this, right? So which option is true? A and D options are my correct options. Okay. Now, next thing we have here is the question from matrices. It says that which of the following statement is are true? So the first statement is there exists a matrix M belongs to 2 cross 3, right? P belongs to R square, Q belongs to R square, such that Mx is equals to P has a unique solution and Mx is equals to Q has infinite solution. When we have two equations and three variables, M belongs to 2 cross 3, so that means we have two equations and three variables. So one variable is always free because rank is always less than number of variables. Rank is always less than equal to 2 and we have number of variables 3. So in this case we have always infinite solution, unique solution, never possible. So that means option A is incorrect. Let's go for option B. M is a 3 cross 3 matrix. They are saying that Mx is equals to P has a unique solution and Mx is equals to Q has an infinite solution. So we know that this matrix has, this system has a unique solution when when rank of M is equals to rank of augmented matrix is equals to number of variables, that is 3 in this case. So rank of M is 3 here. So in this case, infinite solution we have when rank of M and rank of augmented matrix is less than equal to 3. But here rank of M is already 3. So that means in this case we do not have infinite solutions. So if it has a unique solution, B is also incorrect. Now for C option, it says that M belongs to 3 cross 2 matrix, right? P belongs to R cube, Q belongs to R cube. They are saying that Mx is equals to P has a unique solution and Mx is equals to Q has no solution, right? Now let's see one thing here. Three equations, two variables. So Mx is equals to P can have unique solution. When it would have unique solution? When rank is equals to 2 and Mx is equals to Q has no solution. And Mx is equals to Q has no solution when rank of M is 2, but this Q vector, this rank of M augmented Q has rank 3, right? Augmented matrix can have rank 3 and rank of M is 2, right? So this is true in this case. C is true. Now option D, there exists M belongs to 3 cross 3 matrix, Mx is equals to P has no solution and Mx is equals to Q has infinite solution. Now again, Mx is equals to P can have no solution because rank of M is less than rank of M augmented P, and here rank of M is equals to rank of M augmented Q is less than number of variables, so it can have infinite number of solutions. So D is also true. So here options C and D are my correct option, right? Based on system of linear equation, you just have to verify that when these two cases would be possible. Now, next question we have is X be a random variable uniformly distributed in the interval 1, 3, Y be a random variable uniformly distributed in the interval 2, 4, X and Y independent of each other, then we have to tell them probability X is greater than equal to Y. We have to tell them this. So for this X variable, what is the probability distribution? 1 by 2. For this Y variable, we have probability distribution 1 by 2 because this is uniform distribution. So let me write down this clearly. X has probability 1/2 on the interval 1, 3. Y has probability 1/2 on the interval 2, 4. I have to find out probability X is greater than equal to Y. That means I have to take both the probabilities 1/2, 1/2, dy, dx, and y started from 2 but goes up to x. Y goes from uh, okay, y goes from 2 to x, right? Then y would be greater, na? 2 to x. Y can go from 2 to x, and x can go from 1 to 3. No, because I have to take x is greater than equal to y, so it would go from 2 to 3, because then we have the possibility, na? We have the possibility then x is greater than y when x sorry x is greater than y, right? We have this probability that y is less than x when x lies between 2 and 3. If x lies between 1 and 2, then it is always less than x is always less than y, right? So that's why. So let's solve this 1/4, and if I'll integrate, I'll get x minus 2 dx. So let's integrate 2 to 3. 1/4 x square by 2 minus 2x from 2 to 3. 1 by, okay, sorry, this is 4, not 2. This is 1/4. Right, let's solve it. 1/4, 9/2 minus 6 minus 4/2. Minus 4/2 is minus 2 plus 4, right? We'll get this. So on solving, minus 8 plus 4, we'll get 1/4, 9/2 minus 4. That would give me 1/4 into 1/2. That is 1/8. So on solving, I'll get 0.125 as my probability. Right, 0.125 is my probability here. Okay, now let's see next question. So we have this question: two fair coins are tossed independently. X is a random variable that takes a value of 1 if both tosses are heads and 0 otherwise. Okay, let's write it down first. X is a random variable that takes a value, probability X is equals to X. It takes a value 1. Okay, it's not probability. First of all, I am writing cases first. If X takes value, both tosses are heads, then X takes value 1. And if otherwise, head tails, tail head, and tail tail, in this case X takes value 0. So that means I can say that probability of X is equals to 1, that is 1/4, and probability of X is equals to 0 is 3/4. That is first case. Now another case is y. Y is a random variable that takes a value of 1 if at least one of the tosses head and 0 otherwise. That means y is equals to one of the head tail, tail head, and head head. In this case it takes value 1 and it would take value 0 when we have true tail tail, right? So can I say that probability y is equals to 1 is 3/4 and probability y is equals to 0 is 1/4. Now they ask me covariance of x and y. So formula for covariance of x and y: expectation of xy minus expectation of x into expectation of y. So what would be expectation of x? So if I'll find out expectation of x, 1 into 1/4 plus 0 into 3/4. So it would give me 1/4. Expectation of y would be 1 into 3/4, 0 into 1/4. So we'll get 3/4, right? Now next thing is that I have to find out expectation of xy. For that I have to find out joint random variable. So for joint random variable, let's write down x and y. So x, y, right? This is for x, right? Now for x, let's say x can take value 1 and 0, y can take value 1 and 0. X is 1, y and 1 when x and y are 1, when we have head head, right? When x is 1, y is 0, it is in 0 cases. X is 0, y is 1. X is 0 and y is 1. So we have two cases here, head tail and tail head, and in this case we have tail tail. So now I can write down the probability. Let's write down the probability x, y. So probability would be 1 0 1 0, 1 by 4, 2 by 4 and 0, and it would be 1 by 4. Now if I'll find out expectation of xy, that means 1 into 1 into 1 by 4 plus 0 into 1 into other terms would be 0, because every term would have 0. So I can write down here expectation of xy is 1 by 4. Now let's solve. Covariance of xy is expectation of xy minus expectation of x, expectation of xy minus expectation of x into expectation of y. That means 1 by 4 minus 1 by 4 into 3 by 4. That means 3 by 16. 1 by 16 or 4 by 16 minus 3 by 16. That means 1 by 16. That means 0.0625. So this would be the answer. Right? So that would be the answer, covariance of x and y. Okay, so now let's move to the next question. So this is a question. It says that h represents height, I represent number of internal nodes, L represent number of leaf nodes, and N represent total number of nodes in a rooted binary tree. Which of the following statement are always true? Right? So let's see. In a rooted binary tree, that means we have a binary tree in which we can have at most 2 child, right? Any node can have at most 2 child, right? And this node I'll say as a root node, right? And these are my leaf nodes, right? These are my leaf nodes, and these all would become internal nodes. Okay, now they are saying that which of the following statement is always true? So h height is less than equal to number of leaf nodes less than equals to 2 to the power h minus 1. So in binary rooted tree, I know that at most can have 2 children, right? So can I write down this is what? This is my binary tree, right? Rooted binary tree. And here height is 3. Height is 3, and if I'll talk about number of leaf nodes, 1. So that means A option is incorrect. A option is incorrect. Now length is less than equal to I plus 1. Let's take another type of, right? Let's compare the results in both the cases, in both type of cases. L is number of leaf node is always less than equal to I plus 1. I is what? Number of internal nodes. So I can see that number of internal nodes here 3. So it would work in this case. And if I'll see in this case, so we have 3 internal nodes, 4 leaf nodes. So 4 is less than equal to 3 plus 1. So this is also true. And you can verify this as well, that height of a tree is always less than equal to number of internal nodes. So you can see that here number of internal nodes 3 and height is 3. So 3 is less than equal to 3, and in this case this is also work, because you can see that height is 2 and I is number of leaf node, that is 4. Right? Similarly, and this one 2 to the power h plus 1 minus 1, that would be the maximum height, right? Maximum number of nodes a binary tree can have. So both the options are correct. So here B, C, D are my correct option. Only A option is incorrect. Okay, now let's see. So this is another question. It says that x be a random variable exponentially distributed with parameter lambda greater than 0. Probability density function of x is given by lambda e to the power minus lambda x. So that means this is my exponential distribution. And they have given 5 into expectation of x is equals to variance of x, where expectation and variance indicate the expectation and variance. We have to find out value of lambda. So in exponential distribution, I already told you to remember all the variance and expectation for the distribution, for different type of distribution, right? We have discussed this as well in classes. So like you can see that we have one question from Bayesian directly, and we have one question from exponential, right? So expectation of x would be 1 by lambda, and variance of x would be 1 by lambda square. So 5 into 1 by lambda, and variance of x would be 1 by lambda square. So 5 lambda, 5 lambda square, and I can write down this as minus lambda equals to 0. So lambda 5 lambda minus 1. Lambda into 5 lambda minus 1. So either lambda can be 0 or lambda can be 1 by 5. That is, lambda cannot be 0 because this, if lambda is 0, whole probability distribution would become 0. So lambda would become 1 by 5, that is 0.2. So 0.2 be the correct answer. 0.2 would be the correct answer here. Okay, now let's see next question. Okay, so this is another question. It says that let game ball comma rugby be true if the ball is used in rugby and false otherwise. Shape ball comma round be true if the ball is round and false otherwise. S1 says that for all ball, negation of game ball comma rugby imply shape ball comma round. For ball, negation of shape ball comma round implication game ball comma rugby. For all ball comma game ball comma rugby imply negation of shape ball comma round. For all ball shape ball comma round implication negation of game ball comma rugby. So they ask that all balls are round except balls used in rugby, right? So that means all balls are round except balls used in rugby. So you can see that we have given that S1 and S3, S1 and S2, S3 and S4, S2 and S3. So that means which of the option gives me the correct answer for this. So let's see. S1 and S3, or S1 and S2, S3 and S4, and S2 and S3. S1 and S3 for all ball, right? Negation of ball. If ball is not rugby, if game ball comma rugby says that ball used in rugby, if the ball is used in rugby. Okay, so if ball is used in rugby, okay, so it means that if ball is not used in rugby, then shape of ball is round, right? And it says that all balls are round except balls used in rugby. And if I'll see S3, if ball used in rugby, then shape of ball is not round. So you can see that we are getting if and only if condition. Negation of game, then we have a ball shape, round shape. If we have a round shape, if we are not using a rugby, if we are using a rugby ball, then it is a shape round, right? So that means S1 and S3 are correct. So that means S1 and S3 gives me correct. S1 and S2, S1 and S2 negation of game imply, that means if ball is not rugby, then ball is not round, then ball is round. If ball is not round, then ball is used in rugby. If ball is not round, then it is used in rugby. All balls are round except balls used in rugby, right? So you can check by yourself that, just read the statement 2-3 times, you would get it that option A and option D gives you the correct answer. S1 and S3 and S2 and S3, otherwise no other option gives you correct option, right? So here option A and D are correct option. Okay, so A and D are correct. Now next we have this question, select all choices that are subspaces of RQ. So to form a subspace, first of all, we have to form a subspace, we have to use two rules. That if u comma v belongs to W, if W is a subspace of V, W is a subspace. Let me write down. W is a W is a subspace of V if U plus V belongs to W and C into U belongs to W. If these two conditions hold. So let's suppose if I'll find out any solution from these two, then some of those two solution would be also in this space. And if I'll multiply any constant, let's say if I'm getting solution x1, x2, x3, then cx1, cx2, cx3 would be the solution, right? So this is a subspace. And if I'll talk about this, in this you can see that we have alpha square plus beta square. So that means we have only positive values. So there may be a possibility that if I'll take c negative number, right? If I'll take any c value that is negative, so that would not belongs to this set. So that's why this is not a subspace. This one, this would again form a subspace. You can see that 1 1 0 and 1 0 0, it would be a combination of that. So if I'll take any two vectors, something like that, it would again, you will get a combination, and if you would multiply with the scalar, you would get a combination. Now let's see last option. Last option, we have a constant in addition, so that's why it is not a subspace. So D is not a subspace. When you have a constant in addition, if you would take it to the right hand side, -4, if you would take any two solution x1 x2 and x1 dash x2 dash, then x1 plus x1 dash comma x2 plus x2 dash does not become the solution, right? So that's why uh, only option A and C are correct. B and D are incorrect option. So this is a question. It says that consider two events T and S, and T bar denote the complement of the event T. The probability associated with different events are given as follows. Probability of T bar is equals to 0.6. Probability of S given T is equals to 0.3. Probability S given T bar is equals to 0.6. So we have to find out probability T given S. So first of all, let me check what do I want to find out for probability T given S. So I want here probability T intersection S upon probability of S. So probability T intersection S I can find out from here. Probability S given T is given to me 0.3. So I can write down probability S intersection T upon probability of T is equals to 0.3. And probability of T I can find out from here. Probability T bar is 0.6. So probability of T would be 1 minus 0.6, that is 0.4. So if I'll write down here, I'll get probability S intersection T into probability T goes to the right side, 0.3 into 0.4. So I'll get the probability, that is 0.12, right? Now, next thing we have is probability S given T bar. I have to find out probability of S. So, by law of total probability, can I write down probability of S would be probability of S given T bar into probability of T bar plus probability of S given T into probability of T, right? I can do that. Now, I have to just fill all the values, right? Using law of total probability, I have written this. Now I can use all the probabilities. S given T bar is 0.6 and T bar is 0.6 probability. Okay. Probability S given T. Already I have 0.3 and I found out probability of T, that is 0.4. So we'll get 0.36 and 0.12. So we get here 0.48. Right. So let's write down 0.12 upon 0.48. So we'll get 1 by 4, that is 0.25 is my final probability, right? So this is a question based on probability. Okay, now next we have here is question. Consider the following sorting algorithm: bubble sort, insertion sort, selection sort. Which one among the following choices of sorting algorithm sorts the array 43215 in increasing order after exactly 2 passes over the array? So after exactly 2 passes, which would give me the sorted array? So 43215 is for my array. So let's see, 43215. So if I'll talk about bubble sort, what bubble sort would do? It would take this 4 and it would try to put it, it would try to swap, right? So in first pass, what would I get? 4, it would check that 4 is greater than 3. So it would become 34215. Then it would check 4 and 2. So it would become 32415. Then it would check 4 1. So we'll get 32145. So in after first pass, we'll get our array like this, 32145. Now in the second pass, again I have to check, I have to put 3 it's at its correct position. So I'll check 3 and 2. So that is if I'll swap 3 and 2. So first check 3 is less than 2. Okay, 3 is not less than 3, sorry. So I'll check here. So I'll check here 3 is not less than 2. So it would become, if I'll check 2, 3, 1, 4, 5, again 3 is not less than 1. So it would become 2, 1, 3, 4, 5. Right. So after the second pass, I'm getting this array 2, 1, 3, 4, 5. This is not a sorted array. Right. This is not a sorted array. So that's why I'll say that in bubble sort, it would not work. Now in insertion sort, so I'll see that 4, 3, 2, 1, 5. So I'll divide it right in 2 parts and I'll see that this 4 is sorted. This first half is sorted. Now I'll put this 3 at its correct position. So I'll check 3 and 4. 3 is small. So I'll write down 3, 4, 2, 1, 5. So this part is sorted. Now I'll check for 2. Again I'll put 2, 3, 4, 1, 5. This is sorted, but this is not sorted. In the second step, I'm not getting a sorted array. So insertion sort is not giving me after 2 passes sorted array. Now if I'll talk about selection sort, what would it would do? It would find out the smallest element. So 1 is the smallest element and it swaps with the first element. So what would I get? 1, 3, 2, 4, 5. Now it would find out the second smallest element and it would replace it with the second one. 1, 2, 3, 4, 5. So you can see that in selection sort, we are getting a sorted array, right? In twos, exactly two passes. So which option is true? Option B is true here, right? B is the only true option here. Now, next we have is consider the following figures representing data sets consisting of two-dimensional features with two classes denoted by circles and squares. So we have to tell them that first is linear, second is linearly separable, third is linearly separable, fourth is linearly separable, and first is linearly separable. So we have to check that. So I can see that in first option, if I'll see these are linearly separable, this is linearly separable, this is not a linearly separable data, right? You can check that directly. This is also not linearly separable, but if I'll check this is a linearly separable data, right? So first and fourth are linearly separable, but second and third are not linearly separable. So I can say that C and D are my correct option. Okay, so that's how we are going to solve all the questions. So this is all about the paper we have for GATE data science. So that's all from our side. Thank you.
Hello everyone. Now in this session we are going to discuss about the general aptitude question of a data science and artificial intelligence paper, GATE 2024 paper that has already done. So we are going to discuss the solution part, we are going to discuss the question, the methods, how they have solved each and everything. Plus one more thing you need to remember, then while I'm solving the paper, it might be possible because the questions and options are shuffled. So if I'm saying so for the question number 2, the option number 3 is accurate. So don't go with the question number 2 and 3. Check the questions manually, which questions is falling in which category of yours first. Second, my option number 2 will be option number 4 of yours in the paper. So it might be possible that the options are shuffled. That's why keep check in this mind that you have to check the question paper manually plus the options are manually, and whatever the options I have mentioned, okay, the numeric value you will check, not the ABCD you will check. Okay, so let's start our first question. The sum of the following infinite series is equal to 2 plus 1 by 2 plus 1 by 3 1 by 4 1 by 8 1 by 9 1 by 16 1 by 27. Okay, so if you remember the GP series, and this is the basically the summation of a GP series. Okay, so we can rewrite these things like 2. Okay, so this will be 2. Okay, so this will be 2 plus 1 by 2. Okay, then we can write as a 1 by 4 plus 1 by 8 plus 1 by 16 as a combination of like this. Then the next one it will be 1 by 3 1 by 3 plus 1 by 9 plus 1 by 27. Okay, these GP series are making, now if you are solving this paper question, so if I'm taking 2 as a common, sorry, if I'm taking as a 2 plus 1 by 2 as a common, okay, so this will be equal to 2 I'm taking common, then the series will be like this. So this will be 2 plus 1 by 2 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, something like this. It will carry on. For 2 it's 2 to the power 1, it will be 2 to the power 4, it will be 2 to the power q, right? This will go to infinity. Plus if I'm taking 1 by 3 from here common, 1 by 3, then that will be 1 plus 1 upon 3 plus 1 upon 3 square, and something like that it will go. Okay, so this will be equal to 2 plus 1 by 2 into, if you remember this is the GP series, a upon 1 minus a upon a minus r. Okay, so a upon a is equal to 1 1 minus r 1 by 2, 1 upon 1 by 2, that will be equal to 2 plus 1 upon 3 into, this will be again a upon 1 minus r. So a is equal to 1 and 1 minus r 1 upon 3. Okay, so 1 upon 3 2 by 3. Okay, so that will be equal to 3 by 2, 3 by 2, right? I'm removing this one. Okay, so this will be equal to 2 plus 1 plus 1 by 2. Okay, so this will be equal to 4 and 4 to 6 and 7 by 2. Okay, so the answer is equal to 7 by 2. Now checking to the options, option number A, from mine the option number is 7 by 2 is accurate. From your answer it could be different, your options could be different, so just match your answers. Okay, the three different views of a dice are shown in the figure below. The piece of paper that can be folded to make this dice is equal to. Now see, This is completely kind of an imagination part, that how you can imagine the question, how can imagine the solution for the respective questions. The problem of the dice, the problem of the mirror image, the paper folding concept, the specific concept not do not have any kind of a certain formula to solve these kind of a question. You have a very good command on the you have a very good mental ability to rethink about these things and reshape about the dice thing, right? I'm just directly coming to the options. Okay, as you can see, the first point is 5555, so we don't have to check. Okay, the second point is 1111, we don't have to check, right? First, once it's the top, now you have to imagine. Okay, if you imagine the dice, then on that basis you will understand. For the 4, okay, for the 4, this is just a rotation. So for the 4, this part is equal to 3 and this part is equal to 6, like this it's moved. Okay, on the basis of that, if you have a good imagination, you will easily understand this question, because only the three part is coming. So there could be a confusion of a and c, because see, this and this is by default cancel, only the confusion part is a and c. Okay, because this part and this part is matching for these three. Okay, now only one thing is the point of this. Okay, on the basis of point of this sixth part, okay, you got the correct answer for this. So the answer for this question will be option number a, that is the 514623. Remaining all three are incorrect, right? Next, if arrow denote the increasing order of intensity, that meaning of a word sick, inform, and moribund. Okay, sick, it means that we are just not well. Okay, the initial phase. Then inform, it means that our condition is not getting good for the so many days, so we will be termed as an informed. And moribund, it means that just it's a kind of a thing that you are that it will about to kill you. Okay, so this is the intensity, right? Same silly, then fawn from, that will be not vain, and van, that could be options. So option A. Okay, vain. So silly, vain, and draft, this could be the answer for this option. This will be the answer. Okay, here the person 1 and person 2 have invested in the mutual fund A and B, okay, and C. The amount of invested each are giving as a fund as a person 1, person 2, mutual fund A, B, C, 10, 20, 20, 20, 15, 15. At the year of a 1 year, the total amount of a person 1 is getting 500 rupees more than the person 2. The annual rate of return or the mutual fund B and C is 15% each. Okay, so for this question, can we do this thing like, see, I'm assuming for that it has a x% and it has a x%. Okay, because for the rate of return for the B and C is 15%. So for them 15% is given, for them 15% is given, 15% is given, 15% is question is very easy. Okay, now what is the annual rate of return for the mutual fund A? Okay, so if annual rate of return for the mutual fund A we have to find out, but there is a one more relation has given, that is the amount of the person A is getting as 500 rupees more than the person B. It's a very simple calculation part. Okay, so the person A and person B, so person A minus person B, that has a 500 rupees difference. Okay, if you just do the basic calculation, that is the basic mathematics. For that, the question 10%. Okay, the basic calculation part is only here. 10% is the final answer for this question, right? Visualizing the Visualizing two identical right circular cone, okay, such that one is inverted over there in such that they have a common circular base. Okay, something like this. Okay, and so the second one is, okay, so I'm just trying to make things like this. Okay, visualizing two identical right circular cone such that one is inverted over the other in such a way they share the common circular base. They have a common circular base. The cutting plane passing through the vertex. Okay, the assembled cone, then what is the shape of a vertex? Okay, so vertex, it means it will be like this. Okay, this is not the hexagon, confirm. This is not going to be triangle, ellipse. That is certainly a rhombus, 100% sure. The 15 part of the given figure are to be painted such that the no two adjacent part will the share boundaries, okay, excluding corners. So we have to exclude the corner for the same color. The minimum number of a color is required is equal to what? So minimum, okay, 15 parts of the given figure are painted. 15 parts of the given figure are painted in such that no two adjacent parts share the common boundaries. It means that if we are this than this, not like this, okay, that we are not going to consider. If we have considered this than this, okay, so minimum we have to cover. Option is 4 5 3 6. For 3 it will not work, okay, at least we have a minimum 4, okay, because for the diagram, if you can see, there are 15 diagrams. Shared boundaries, that is not excluding the corner, that's why at least we have a 4 corners, at least we have a 4 number of a colors, sorry, 4 numbers of colors are required, so that they have not any shared boundaries, okay. So for that the option is equal to A, or 4 is a correct answer for this question. Next, in election, the share of a valid vote received by the four candidates A, B, C, D is represented by the pie chart shown. The total number of a vote cast in the election is 115,000, and out of which 5,000 is invalid. Based on the data provided, the number of a valid vote received by the candidate B and C is equal to what? So B and C are constituting how much vote? They are constituting 20 plus 25. Okay, that is equal to 45% vote. Okay. Now we have a 115 votes and 5 are invalid. It means that the valid vote is equal to what? Is equal to 115,000 minus 5,000 is equal to 110. Okay, this is the valid vote percentage, right? And we have to find out the B and C contributions. So 110, 45%, 45%. Okay, this will be equal to 0. Okay, now they are asking, based on the provide, the total number of valid vote received by B and C is equal to what? So this is the basically, if you are solving this, so the valid vote is equal to 49,500. Just a simple mathematics. 49,500, 49,500. Option C is the correct option for this. How many four-digit number can be intentionally formed? Okay, so for this question, there are a multiple possibility. The first thing you need to understand what is exactly the divisibility by the three things. Okay, so if you understand the divisibility by three, then you can have a better idea. For divisibility of three, you have only remember one thing, that if the number we are adding, then these numbers should be getting if the number is added, then this number should be divisible by 3. Okay, so the numbers are 134, 134, 6, 7. Okay, we have to make the combination in such a way that the number is divisible by 3 also. Okay, so if you add this number 1 plus 3, 4, 4, 8, 8 and 16 and 21, it means that all the number, if you are combining, then the number are divisible by 4. If I'm removing 1, okay, then it will not divisible by 4. Okay, it will not divisible by 3. So 1 will be in our set. Since the total number of addition is equal to coming as a 21, okay, so 3 will be also in the picture. 3 will be also could be in the picture. If I'm removing 4, then 4 will be not in our picture. Okay, so the options are coming as, just give me a second. Okay, these are the combinations. Okay, so 1 3 1 3 4 7 and 1 4 6 7. So these are the combination can be made, because of, if you are checking these one, 11 12 15 and 5 12 18. Okay, so in that case, both the numbers, if you are adding, then divisible by 5. For that we have a 4 factorial number possibility. For that we have a 4 factorial number possibility. So 4 is equal to 4 into 3 into 2 into 1, 4 into 3 into 2 into 1, 24. For this it will be 24. If we are adding this one, the 48 will be the final answer for this question. These questions are not difficult. Only one questions I found that there is a good question. Otherwise these still are the easy questions. Thousands of years ago, some people began dairy farming. This coincided with the number of a mutation in the particular gene that has resulted as the people developing the ability to digest dairy milk. based on the given passage what is informed. It means that once they have understand the ability to digest milk, okay, before that they have done the mutation thing. Digestion of the milk is essential for human being, not confirmed from the statement. No human being can digest the dairy milk, not confirmed. Okay, all human being can digest, not confirmed. Only the human being digests the dairy milk resulted from the mutation gene, mutated gene. This is the only option. Okay, the probability of a boy or a girl being born is 1 by 2. For the family having three children, what is the probability of having two girl and one boy? So for this question, the people are got confused because they are getting two answers, either 3 by 8 and 1 by 4. I'm solving this question for the two girl and one boy. Okay, so two girl and one boy. Okay, it will be basically 3C2, right? So if you are solving, so and for this if we have a 3C2, okay, and the family has a two boy, so if we can make a number of a series part from where we can make the number of things from this, the number of people that is inferred from this is the GGB, BBG, BGB, like this, like the things that you have written. So simply for that 3C2 upon 8, for that this is the final. Only one thing you need to remember, okay, for certain people have got the answer for 1 by 4, but once we are talking about the 1 by 4, it means that you are not doing the probability thing, you are taking about the permutations thing. On the basis of that you will get the 1 by 4 answer. That is not correct. Here we are getting for 3C2 upon 8 because we have a certain arrangement, and that's it, right? So we will not solve this question by using the arrangement, by using the permutation. Directly we will solve, and the formula will be 3C2 upon 8. Directly it will be applied, right? So 3 by 8 will be the final answer for this question. Okay, so I believe this is all for the data science and artificial intelligence general aptitude question. Further questions about all the topics will be discussed also. So this is all for this, and the upcoming lectures are also coming. Thank you.